Hello everyone, I am Soham Joshi from Vishwakarma Institute of Technology, Pune. Welcomes you to the video. This is Group 9th of H Division, which will going to cover one of the most important topic of computer organization and architecture. That is, use of address bus, data bus and control bus in von Neumann architecture. Let's get started.
Hello guys, I am Atharva Doshi and today I am going to introduce you to the von Neumann architecture. The von Neumann architecture is a way of designing and building digital computers that was developed by a mathematician named John von Neumann in the 1940s. This architecture uses a single processing unit called the CPU to perform calculations and logical operations on data that is stored in memory. There are three main parts of the von Neumann architecture: the CPU, memory, and the IO devices. The CPU is like the brain of the computer. It performs all the calculations and logical operations that are needed to run programs and perform tasks. The memory is where the computer stores data and instructions that the CPU needs to access. IO devices are used to interact with the computer like keyboard or a screen. To connect these components, von Neumann architecture uses something called buses. Buses like highways that allow data to travel between the CPU, memory, and IO devices. This way, the computer can quickly access the information it needs to perform tasks and complete operations. Overall, von Neumann architecture is a fundamental concept in computer science that helps us understand how computers work and how we can design them to be efficient and effective.
Hello guys, I'm Atharva Joshi and today I'll talk about buses. What is a bus? A bus is a collection of wire through which data is transferred between various parts of a computer. A bus is either an electrical or a digital pathway through which data is transferred in form of bits between various parts of a computer. The data which is transferred in bus is transferred as binary digits, which means that it is either transferred in zeros or ones. The term bus may also refer to a communication pathway because it helps smooth communications between two parts of a computer. Bus is also referred to as a channel which helps smooth communication between two or more parts of a computer. The bus is also referred to as a spinal cord of a computer system because it connects the CPU, which is the main brain of a computer, with various other parts of a computer system. The most important function of a bus is that it allows parallel transfer of data, which means that various amounts of data can be transferred simultaneously through a bus. For example, if there is a 32-bit bus, the data is sent over 32 wires simultaneously. Now, moving on, system buses. So, what is a system bus? System bus is a set of wire that interconnects all the components of a computer system. The system bus has two main components: the source component and the destination component. The source component is a component from which the data is input into the bus, whereas the destination component is a component where the data is offloaded from the bus, which means that the data which is transferred to the bus has its final destination at this point. The system bus has a certain hierarchy. Now, moving on, there are three main system buses. The first one, a control bus, the address bus, and the data bus. Now, the data bus will be discussed by my group mate.
Hello guys, my name is Avish Joshi, roll number 49. So as we have seen, there are three types of system buses: the control bus, address bus, and the data bus. So the first one is the data bus. Data bus is a channel across which the actual data is transferred between CPU, memory, and the input-output devices. The data bus consists of 8, 12, 32, or 64 parallel signal lines. Each wire can transfer one bit of data. So for example, if there are 8 wires, the bus can transfer 8 bits of data at a time. The number of wires in the bus affects the speed at which data can be transferred. The wider the data bus, more data it can carry at one time. The data bus is bidirectional. This means that the CPU can read data from the memory or it can send data out to memory.
Hello everyone, my name is Kailash Joshi and today I'm going to introduce you to the address buses. Buses are a crucial component in the computer architecture that is responsible for transmitting the address of a data from CPU to memory. The address bus is made up of a parallel signal lines which can be 16, 24, 32 in the number. The number of lines determine the amount of memory that can be directly addressed, as each line carries one bit of the address. For instance, if a computer has n addresses lines, it can directly address 2 raised to n address lines. For example, a computer with 32-bit address can address 4 GB of physical memory. So, what does this mean? Well, it means that the size of the address bus directly affects the amount of the memory that can be accessed by a CPU. If a computer has a similar address bus, it can only address a limited amount of memory, whereas a large address bus can address more memory. It's worth nothing that just because the CPU can directly address a certain amount of memory doesn't mean that the computer can have much memory installed. There are other factors that can limit the amount of memory a computer can have, such as the number of memory slots available, the types of memory used, and the operating system's limitation. In conclusion, the address bus is a vital component in the computer architecture that enables the CPU to communicate with the memory. The size of the address bus determines the amount of memory that can be directly addressed and understanding. This concept is important for everyone interested in computer hardware or software development.
Till now, we have seen what is von Neumann architecture and types of system buses such as data bus and address bus. Now we will see what is control bus. So the data and address lines are shared by all components. There must be a means of controlling their use. So this is where a control bus is used. The physical connections that carry control information between the CPU and other devices within the computer. This bus is mostly a collection of unidirectional signals. It is the path for all timing and controlling functions sent by the control unit to other units of the system. Timing signals indicate the validity of data and address information, while command signals specify operations to be performed. Typical control signals include signals such as read and write signals, interrupt signals, clock signals. One example of line on control bus is memory read or write signal, which is used to indicate whether CPU is currently reading from or writing to main memory. Another example of a line on control bus is IO read or write signal, which is used to indicate whether the CPU is currently reading from or writing to an IO device. These lines on control bus are critical for coordinating the different operations of the computer system. In summary, the control bus is an important component of a computer system as it enables the CPU and other components to communicate with each other and coordinate their activities effectively.
Till now, we have seen what is one human architecture and what are the different types of serial buses that are used in one human architecture. It's time to see the advantages and benefits of one human architecture. Comparing one human architecture with other computer designs, there are various benefits. Its largest advantage is that it simplifies the microcontroller chip design because only one memory is accessed. This means it is very simple to design and construct the von Neumann architecture. Second most important advantage is its flexibility and adaptability. It means it enables to be utilized for a variety of applications. Additional to this, the use of a single processing unit and shared memory reduces the overall cost of the system and reduces the complexity of the system. So that's all for today. Thank you and have a nice day.